We humans live with uncertainty every single day, right? We make bets, we make plans, we make decisions, all of it based on information that's, well, incomplete. But how does a machine, something built on pure logic and rules, handle a world that's just inherently messy and unpredictable? That's exactly what we're going to dive into.
I mean, think about a super simple question you probably ask all the time. You check the forecast. But even the most advanced weather models, they can only give you a probability, never a 100% guarantee. It's a perfect little example of us trying to navigate the unknown. Or, hey, what about the world of finance? Analysts crunch just endless amounts of data. But at the end of the day, any prediction is still just a prediction. There are way too many variables, too much missing info to know for sure. It's basically a massive, high-stakes gamble. Okay, but now let's really raise the stakes. This isn't just about, getting caught in the rain or making a bad investment. For an AI, learning to handle uncertainty isn't just some interesting puzzle, it is the central challenge it has to overcome to operate safely and effectively in our world. So all of these questions, they're all pointing to one single core concept. Before we get into how AI tackles this whole problem, we need to be crystal clear on what we're actually talking about. At its heart, uncertainty is really just a gap in our knowledge. The data is incomplete, maybe it's even contradictory. And when an AI runs into this, it can't just compute a clean, simple answer. And the real world, let's be honest, it's nothing like a clean data set. It is absolutely filled with these gaps. And this, right here, creates one of the biggest hurdles for artificial intelligence. We want machines to act in the real world, but the real world is fundamentally uncertain. So let's look at a couple of key examples to see why this is just so tough. A self-driving car can be trained on millions of miles of road data. It knows to stop at a red light, it knows to slow down for a pedestrian in a crosswalk, sure. But what happens when something completely, totally unexpected happens? A deer suddenly leaps onto the highway at night. That's a chaotic, uncertain event you can't perfectly program for. And you see the exact same challenge in medicine. An AI can analyze a patient's entire history, their lab results, thousands of medical scans, but there can still be missing information or symptoms that are vague and ambiguous. A 100% certain diagnosis is often impossible, even for a super powerful machine that has access to nearly infinite data. So, this really is the million-dollar question, isn't it? If the world is inherently uncertain and machines kind of need certainty to operate, how do we possibly bridge that gap? How can a machine make a smart, reliable decision when it just doesn't have all the facts? Well, the answer is surprisingly elegant. Instead of trying to force certainty on an uncertain world, we teach the machine the language of uncertainty itself. And that language is math, specifically the math of probability. So, get this. Instead of trying to get rid of uncertainty, which, let's face it, is impossible, AI uses probability to manage it. It gives the machine a framework to quantify its own doubt and make reasoned judgments in spite of it. And this right here is the concept that just changes the entire game. A world of maybes and what-ifs is totally paralyzing for a logical machine. But probability allows an AI to assign a numerical value to every single maybe. It can calculate the likelihood of different outcomes, and that turns a fuzzy, vague guess into a solid piece of data it can actually work with. We can see this powerful idea in action with something super simple, a standard deck of playing cards. This is where the abstract really becomes concrete. Okay, so we've got a standard deck of 52 cards. Our goal is to figure out the chance of drawing a red one. The key fact we know is that exactly half the deck, 26 cards, are red. So the math is pretty straightforward. We just take the number of outcomes we want, 26, and we divide it by the total number of possible outcomes, 52. And boom, the result is 0.5 or 50%. In that one little calculation, the AI has moved from a state of, I have no idea, to there is a 50% probability. It now has a specific, measurable value it can use to make a decision. This is the very first step in reasoning under uncertainty. But here's where AI gets even smarter. It updates its beliefs when it gets new information. So imagine we want to know the chance of drawing a diamond. At first, that's 13 out of 52 cards, right? A 25% chance. But now, what if we get a new clue? We're told the card is red. This changes everything. This is what's called conditional probability. Our whole world of possibilities shrinks from 52 cards down to just the 26 red ones. And within that smaller group, 13 are diamonds. And just like that, the probability jumps from 25% all the way up to 50%. New information leads to a more refined, more accurate prediction. Okay, now, a deck of cards, that's a nice, simple, closed system, right? The real world is infinitely more complex. So to handle all that messiness, AI needs more than just basic probability. It uses a whole toolkit of really advanced mathematical methods. And folks, this is where things get really powerful. Take Bayesian networks. You can think of them as a way for an AI to map out cause and effect relationships, like how different symptoms might point to a particular disease, and then update its beliefs as new evidence rolls in. Then you've got something like fuzzy logic, which is just fascinating. It lets an AI work with imprecise, human-like concepts. Not just it's 75 degrees, but it feels warm. These are the advanced tools that give AI the sophistication to model the world's ambiguity and make truly intelligent judgments. And all this leaves us with a really fascinating thought to chew on. As these tools become more and more powerful, AI is getting better and better at navigating our uncertain world. From forecasting market trends to diagnosing rare diseases, it's turning maybe into a number we can actually act on. So the real question is, as it gets better at seeing what's coming, where do we draw the line?